Tonight, we are going to talk about something incredibly rare, something that has traveled across the vast emptiness between the stars. A visitor from another solar system. Somewhere, billions of years ago, around a distant star far away in the Milky Way, a small icy world was formed. It drifted through its own planetary system, orbiting quietly around its parent star for millions, perhaps billions of years. Then something happened. A close gravitational encounter with a giant planet may have changed its orbit forever. Instead of continuing its slow path around its star, the object was thrown outward into interstellar space, and so began a journey that may have lasted longer than the entire history of human civilization. 4 billions of years, this small frozen object traveled through the dark space between stars. No sunlight, no planets nearby, only the faint glow of distant galaxies and the silent movement through the Milky Way. Eventually, after crossing unimaginable distances, the object entered a completely different planetary system, our own. In July of 2025, astronomers working with the sky survey system known as Asteroid Terrestrial Impact Last Alert System detected something unusual moving across the sky. At first, it looked like a normal comet. But when scientists calculated its trajectory, they realized something remarkable. The object was moving far too fast to be gravitationally bound to the sun. Its path through space was hyperbolic, meaning it was not orbiting our star at all. Instead, it was simply passing through our solar system on a one-way journey. This object became known as 3I Atlas. The name may sound technical, but it contains an important story. The 3I means it is the third confirmed interstellar object ever detected entering our solar system. The first was the mysterious visitor discovered in 2017 known as Oumuamua. The second was an icy comet called 2I Borisov. But 3I Atlas was different. It appeared to be traveling even faster than the previous visitors, moving at about 58 kilometers per second relative to the sun. That is more than 200,000 kilometers per hour. At that speed, the object was simply flying through the solar system, unaffected by the sun's gravity enough to stay. It would visit once and then disappear forever. Astronomers quickly turned some of the most powerful telescopes on Earth and in space toward the new visitor. Observatories around the world began studying its brightness, its tail, and the cloud of gas and dust surrounding it. Unlike the strange cigar-shaped object Oumuamua, which showed almost no cometary activity, 3I Atlas behaved much more like a traditional comet. As it approached the sun, its icy surface began to heat up. Frozen gases inside the object started to vaporize, creating a glowing cloud called a coma, along with a long tail of dust stretching millions of kilometers behind it. But even though it looked like a comet, scientists quickly noticed something unusual. Its chemical composition appeared different from most comets in our own solar system. Some observations suggested that its coma might contain unusually large amounts of carbon dioxide and other exotic gases. This could mean that the object formed in a very different environment, perhaps around a star with different chemical conditions than our sun. In other words, 3I Atlas might be a sample of material from another planetary system. Imagine holding a rock that formed billions of years ago around a completely different star. That is essentially what astronomers were studying. Even more fascinating, some scientists believe that 3I Atlas could be incredibly ancient. Because of its trajectory and speed through the galaxy, it may have originated from a very old population of stars in the Milky Way. If that is true, the comet could be up to 11 billion years old, older than our solar system itself. That would make it a kind of cosmic fossil, a relic from the early history of our galaxy. But perhaps the most fascinating part of this story is how rare such visitors are. Our solar system is surrounded by trillions of icy objects in the distant Oort cloud. Some of these objects occasionally fall inward and become the comets we see in our skies. But objects like 3I Atlas come from outside the solar system entirely. They are wanderers of the galaxy. Astronomers believe that countless interstellar objects may exist in the Milky Way, ejected from planetary systems during the chaotic early stages of planet formation. Every time a giant planet like Jupiter shifts the orbit of a smaller body, it can fling that object into deep space forever. Over billions of years, this process may have filled the galaxy with trillions of rogue comets and asteroids drifting silently between stars. Most of them will never encounter another planetary system again, but occasionally one passes through. And when that happens, scientists receive a rare opportunity, a chance to study material that formed around another star, a messenger from a distant world. And that is exactly what 3I Atlas may be, But as astronomers began studying this interstellar traveler more closely, they noticed something else that made the object even more mysterious: strange jets of gas, unusual changes in its tail, and behavior that hinted that this visitor might not be quite like the comets we are familiar with. So the question began to emerge: what exactly is 3I Atlas? And what secrets might it carry from the depths of interstellar space? As telescopes around the world continued tracking the strange visitor known as 3I Atlas, scientists began studying its motion with extreme precision. Every night, observatories recorded its position against the background of distant stars. By measuring these positions over time, astronomers could calculate its exact trajectory through the solar system. And what they saw confirmed something extraordinary. This object had not originated anywhere near our Sun. Instead, its orbit was extremely elongated, what scientists call a hyperbolic trajectory. In simple terms, that means the object is not gravitationally bound to the Sun at all. It is simply passing through our planetary neighborhood once before continuing its endless journey through the galaxy. This kind of orbit is extremely rare. Almost every comet we observe normally belongs to the solar system. Many come from the distant spherical cloud of icy bodies known as the Oort cloud. Objects from the Oort cloud can take thousands or even millions of years to complete an orbit around the Sun, but eventually they return again. But an interstellar object is different. It arrives from outside and it never comes back. The first known interstellar visitor discovered by astronomers was Oumuamua. When scientists first observed Oumuamua in 2017, they were confused by its strange behavior. It appeared to accelerate slightly as it left the solar system, even though it showed almost no visible comet tail. Some researchers suggested that the acceleration could be caused by invisible jets of gas escaping from its surface. Others proposed more unusual explanations. Because of its unusual shape and motion, a few scientists even speculated that Oumuamua could be some kind of artificial object, perhaps a piece of ancient alien technology. However, most astronomers now believe it was probably a natural object, possibly made of unusual materials such as frozen hydrogen or nitrogen ice. Then, in 2019, astronomers discovered the second confirmed interstellar visitor, known as 2I Borisov. Unlike Oumuamua, Borisov behaved very much like a typical comet. It had a bright coma, a long tail of dust and gas, and chemical signatures that were somewhat similar to comets in our own solar system. But even Borisov still contained subtle differences that hinted it had formed around another star. Now, with the discovery of 3I Atlas, astronomers suddenly had a third example of these rare interstellar travelers. And every new example helps scientists understand something important. Planetary systems throughout the galaxy may be constantly ejecting objects into interstellar space. During the early stages of planet formation, large planets like Jupiter can gravitationally scatter smaller bodies, comets, asteroids, and icy fragments, sending them flying out of their home systems forever. Over billions of years, this process could populate the Milky Way with trillions of wandering objects drifting silently between stars. Most of them will never be seen. They travel through the darkness for millions or even billions of years without passing close to any star. But occasionally, by incredible coincidence, one enters the solar system. That is exactly what happened with 3I Atlas. As the object approached the Sun, its frozen surface began warming. This caused volatile materials trapped inside the comet to sublimate, turning directly from ice into gas. The escaping gas produced jets that pushed dust and particles away from a nucleus, forming the glowing coma and tail visible to telescopes. But these jets can also have another effect. They can slightly alter the motion of the comet. Tiny forces produced by these jets can change the object's trajectory in subtle ways, a phenomenon known as non-gravitational acceleration. Astronomers carefully monitored these effects in order to learn more about the composition of the object. Different types of ice vaporize at different temperatures. For example, water ice becomes active relatively close to the Sun, but carbon monoxide and carbon dioxide can vaporize much farther away. By measuring when the comet becomes active and how its brightness changes, scientists can estimate what materials might be hidden inside it. In the case of 3I Atlas, some observations suggested that the object might contain large amounts of carbon-rich material, possibly formed in a colder region of its original planetary system. This raises a fascinating possibility. If interstellar objects like this are common, they could carry materials from one star system to another. Some scientists even wonder whether such objects might have played a role in spreading organic molecules across the galaxy. This idea is related to a concept known as panspermia. According to this hypothesis, the basic chemical ingredients for life, or even microscopic life itself, might travel between planets and star systems aboard comets, asteroids, or other rocky bodies. Over billions of years, this process could distribute organic materials across enormous distances. While there is no direct evidence that life is spread this way, the discovery of interstellar objects makes the idea slightly more plausible. Each of these visitors could carry complex organic molecules formed around distant stars. And when they pass through systems like ours, some of that material could be released into space. Of course, detecting such molecules is extremely difficult. Interstellar objects move incredibly fast, and they remain visible to our telescopes for only a short period of time. Still, each discovery offers a rare opportunity, a glimpse into the chemistry of another solar system, a traveler that has spent millions of years drifting between stars. And as astronomers continued studying 3I Atlas, they began asking an even more ambitious question. What if one day humanity could actually intercept one of these interstellar visitors? What if a spacecraft could fly alongside an object like this, studying it up close before it disappears forever into the depths of the galaxy? Such a mission would be incredibly difficult, but it might also become one of the most exciting scientific adventures in the history of space exploration. And perhaps, sometime in the future, humanity might attempt exactly that. The idea of intercepting an interstellar object might sound like science fiction. After all, objects like 3I Atlas move incredibly fast. By the time astronomers detect them, they are often already moving through the inner solar system at tens of kilometers per second. Planning and launching a spacecraft fast enough to catch up would be an enormous challenge. But scientists have already begun thinking about how such missions could work. One proposal being studied by researchers and space agencies is called Project Lyra. This concept was originally designed after the discovery of Oumuamua. By the time astronomers realized what Oumuamua was, it was already leaving the solar system. There was no chance to send a spacecraft in time, but Project Lyra asked an interesting question. What if we prepare in advance? Instead of waiting until an interstellar object is discovered, scientists could design spacecraft that are ready to launch quickly when a next visitor appears. Such a spacecraft would need extremely powerful propulsion systems, far more powerful than the rockets used during the Apollo program. One possible solution involves gravitational assists. A spacecraft could fly close to large planets like Jupiter or even the Sun itself, using their gravity to accelerate to enormous speeds. Another idea involves new propulsion technologies, such as solar sails or advanced ion engines that can gradually accelerate a spacecraft over long periods of time. If such a mission was successful, it would allow scientists to do something extraordinary. Instead of observing an interstellar object from millions of kilometers away through telescopes, a spacecraft could approach it directly. Cameras could capture detailed images of its surface. Instruments could analyze the composition of its ice and dust. Perhaps even small probes could land on its surface and collect samples. Imagine holding a rock that formed around a completely different star, a piece of material older than our solar system. This would provide scientists with a direct look at the building blocks of other planetary systems in our galaxy. And discoveries like these could help answer some of the biggest questions in astronomy. Are planetary systems like ours common in the Milky Way? Do other systems produce the same types of comets and asteroids? Or are they made from very different materials? Objects like 2I Borisov and 3I Atlas already suggest that other star systems may produce comets very similar to our own, but there may also be important differences. For example, some interstellar objects appear to contain much larger amounts of carbon-rich compounds than typical solar system comets. These differences may reveal clues about how other stars formed their planets. And that leads to another fascinating possibility. Interstellar objects might not just tell us about distant stars. They might also help us understand our own origins. Because long before Earth existed, the material that formed our solar system was drifting through the galaxy as well. Dust, gas, and ice slowly gathered together inside a giant molecular cloud until gravity pulled it inward to form our sun and its planets. But that cloud did not exist in isolation. It was part of the larger structure of the Milky Way. Over billions of years, stars were forming, exploding, and releasing new elements into space. Some of the atoms inside your body today were forged inside ancient stars long before our sun was born. Carbon, oxygen, iron, calcium, All of these elements were created in stellar furnaces and scattered across the galaxy by supernova explosions. In that sense, every planet and every living thing in the solar system is connected to the larger story of the galaxy. Interstellar objects like 3i Atlas are reminders of that connection. They are travelers from distant systems, carrying material that formed in environments we may never directly see. Each one is like a messenger, a small fragment of another solar system briefly passing through our own. And even though these visitors are rare, astronomers suspect that they may actually be far more common than we once thought. The reason we have only detected a few so far is simply because they are small and faint. But new telescopes are being built that will dramatically improve our ability to find them. One of the most powerful upcoming observatories is the Vera C. Rubin Observatory. Located in Chile, this telescope will repeatedly scan the entire night sky with incredible sensitivity. When it begins full operations, scientists expect it to discover thousands of new comets and asteroids, and possibly many more interstellar visitors. Some estimates suggest that several interstellar objects may pass through the solar system every year. Most of them are simply too small or too faint for current telescopes to detect. But as our technology improves, we may begin discovering them much more frequently. In the future, astronomers might observe dozens, perhaps even hundreds of interstellar objects, each one telling a different story about a distant star system somewhere in the Milky Way. And among those travelers, there may be objects even stranger than anything we have seen so far. Perhaps fragments of shattered planets. Perhaps unusual types of ice never found in our solar system. Or perhaps objects that challenge our understanding of how planetary systems form. The discovery of 3i Atlas is only the beginning of this new field of astronomy. For the first time in human history, we are beginning to detect physical objects that formed around other stars. Tiny messengers crossing the vast ocean between solar systems. And every time one appears in our sky, it reminds us of something profound. Our solar system is not isolated. It is part of a vast cosmic network of stars, planets, and wandering objects drifting through the galaxy. And sometimes one of those travelers pays us a brief visit.